We have observed it very detailed. I would appreciate if some of you describes what is that. The normal mucosa is here, and there is something wrong here. What is this organ now? Okay, a colon. Yeah, large intestine could be, yeah, considered. Because we have same structure of large intestine everywhere where we observe it, whether it would be colon or rectum, or even in the appendix, sometimes when it's thicker, we observe the same layers. What we have here is the mucosal layer made of crypts, and as far as you can see, it's pretty much normal. There's some small portion of inflammatory infiltrate here in between the glands, which is actually pretty normal to exist. Even if we observe some lymphatic follicles, as far as you know, this is an organ which is rich in follicles. This one even is trying to make a germ center. It's pretty much normal here. We see lighter fields of glands, no dysplastic changes, simply fine. Later we continue with a field which is suffering some excretion of mucin increased, and there is excreted debris inside in the lumen here, along with some feces. Those darker fields here are actually remnants of food, what we observe. These are also, this is how cellulosis is looking like, with cells that are looking almost empty. And further on the slide, we reach again a field where there is increased excretion of mucin. And we continue now with a place which is mildly dysplastic. So if a clinician takes a pinch biopsy from this place here, I would answer high-grade dysplasia. Make difference between the cells. These are with basally positioned nuclei, with a lighter cytoplasm, looking like daisies. That's how colonic glands are actually looking like. Unlike here, where they're on multiple layers, and the polarity is lost here of the glands, they are also appearing with some irregular forms, not still merging with each other. So that I will mark these changes as dysplastic changes with some inflammatory infiltrate around these. And again, if the pinch biopsy is from here, I will mark this as field of dysplasia. But if the clinician takes a biopsy from this field here, and let's move it even further now here. Take a look at these glands. They are completely changed on multiple layers of cells. Do not think of these as elongated glands, just the cut of the slide is like this. The most important thing yet is that they're on multiple layers with very well marked cellular atypia and prominent eosinophilic nucleoli at each nucleus here and there. Irregular, merging with each other, with lumens which are excreting fluid, but it's not released anywhere, so they are with abortive lumens. Also, pretty much the excretion of mucin is lost. That is what is usually seen in tumors in adenocarcinomas in the large intestine. What else do we see here? We should count all of the cellular atypia features. We should say that these glands are merging with each other and are forming irregular structures on multiple layers, forming some sort of nests here and there. And what is also important about this tumor is the invasion of the tumor. Now it's still making glands, so I can say that it's moderately differentiated about actually this type because it's not having much of mucin excretion, but it's still making glandular structures. What I observe here is the muscle layer, submucosal, where the tumor is invading through. And it's reaching up to the middle layer of muscle cells, but it's not going through it. So that would be helpful for the staging of the tumor. If it's reaching up to the serous surface on the other side of the mucosal layer, of the muscle layer, and in the surrounding fat tissue, then it would be classified in a different T. Now, here what you will be asked is types of tumors that you can expect in the large intestine, majorly adenocarcinomas, adenomas of adenocarcinomas. Eventually, the TNM classification here, what does it mean? I don't think that he would be asking you to classify it and to stage it and grade it, but yet it's good for you to know what does that mean and where does the tumor spread to, and also the differentiation, what does that mean? And I think that is pretty much all about this one. So we marked the field which is normal, we marked the field which is tumorous, and we marked where it's spreading to in the muscle layer, up to it, not going further. We should take a look at this field closer. Now, remembering the cells, take a look at the nucleoli on the inside. Some may be disattached from the tumor and spread further. Take a look at these here and here. It's spreading through the muscle cells, but not going in the serous surface under the muscle layer. And what is that here? That's a very good field now. Take a look at this field. It's perivascular invasion of tumor cells. It's appearing to be looking like this. So this could give rise to tumor emboli and finally metastasis. Where does this tumor most often give metastasis? Where does this tumor metastasize to? Yes, completely correct. We first may observe metastasis in the sentinel lymph nodes, like in each type of epithelial tumors, and later it could give rise to metastasis in the liver due to the circulation of blood.